Okay, good evening, ladies and gentlemen, and welcome to this Saturday evening session of Lean Six Sigma, on Saturdays, generally we go a little deeper in the concepts of Lean Six Sigma, one step further. Okay. So today's concept is just like that, which is how do we handle non-normal distribution data? Okay. This is something very important topic which we are going to cover. Some practical, Minitab exercises also will do. For new people, this will seem like a little advanced topic, a little difficult to comprehend, but don't worry, I will make sure that you will understand everything out of it. Okay. And just be very clear, any question, any doubt you have, please type your doubt in the chat. At the end of the session, we can have an open conversation. You can unmute and speak as well. Okay. So let's begin our session with, I'm sharing my my whiteboard with you. And from there we will start. Okay. Here we go. So today's topic is about handling non-normal distribution. First of all, the first question is, what is a non-normal? What is a non-normal? And what is normal? Let's first differentiate between normal and non-normal. Now, normal is referred to the normal distribution of the data. Now, very logical question is, first of all, what is a normal distribution of the data? Okay. If you see in our, there is a central limit theorem which we are going to do a practical exercise. को practical करके देखेंगे. Okay. It's a universal normal tendency. It's a universal natural tendency when you will collect the data. Okay, when you will collect the data, it will fall under the normal distribution. When I say normal distribution, so let me draw something like here, normal distribution, and here let's say non-normal distribution. Okay. Now let's take a practical example of it, which I always give. Let's say your office arrival timing. Okay. Now most of the offices has the this biometric system, correct? So now if I draw and there are 50 people, this is let's say 9 o'clock, which is the target. Okay. And there are 50 people in your office. All right. Now what will happen is some will come around 8:30. Some will come around 8:40, 8:50, then 9:10, 9:20, 9:30. Okay. So I'm just giving you a very simple example. So out of 50, majority of the people will come around 9 o'clock. Understand this? Majority of them. Some of them will be around 8:30, 8:40, and very few of them will be very early. Similarly, on this side, they will be very close to, this kind of. So if I connect this, it will have a symmetrical distribution shape where maximum data will be lying in the center. And this is called a normal behavior of the process. When there is no abnormality present in the process, this kind of a distribution of the data can be emerged. So these bar graphs, these bars are the frequency. How many people are arriving at 8:30, how many at 8:40, how many at 9 o'clock, etc. Are you clear? This distribution, which also called as histogram, this is a histogram basically. Are you clear how this histogram is formed? And if it is symmetrical, majority of the data in the center, this is called normal distribution. Just give me yes in the chat box if you have understood this, even the new people especially. Clear? This is, and you know why it is called normal? Because normally you will observe the same thing. That's what it's called, normal distribution. Normally you will observe the same distribution pattern. And I always give this example of, COVID wave 1, COVID wave 2, COVID wave 3. This was a normal distribution. See, again, the spread of the data, again, the pickedness of the data, that will change. That will be different. But again, the simple concept is majority of the data will be in the center and that will be symmetrical. Let's come to non-normal data. The same example, one fine day, the biometric system fails. One day the biometric system fails. If we collect the data on the same case, okay, like from 8:30, 8:50, 9, 9:10, 9:30, etc. Okay. Now what will happen is, because the biometric is not functioning, people will start taking. So now 8:30 people will be less. There will be a little less people. You will see a data distribution like this because there is nobody checking. This is called as a skewed distribution. Majority of the people will come after 9:15, 9:20, 9:30. Because there is an abnormality in the process, which is biometric system is not functioning. If you have this kind of a distribution, this is called a non-normal distribution. Non-normal, which is not normal. Again, the same scenario. The majority of the data is not in the center. It is on one side of the distribution. Okay? Are you understanding this? And so, see, this is called the tail. So the bigger tail of this, which side that tail is extending, that is called, for example, this is extending on the left side. So this is called a left hand skewed distribution. If it would have been like this, then it would have been right hand skewed distribution. Right hand skewed का distribution का example है any time related data, delivery time. That's a fantastic example. Let's say pizza delivery. Okay. Let's say 30 minutes is the target time. So if you draw the data like this, you will observe majority of the pizzas are delivered around 20 minutes and 30 minutes. And there are few delays. So if I draw the distribution, it would look like this. It would be a right side skewed, right hand skewed distribution, because then there will be some delay, 40 minutes, 50 minutes, 60 minutes. So there will be a delayed delivery as well. So whenever a delivery data would be there, delivery or time related data, okay, cycle time, your, delivery time, downtime. So time related data, you will see some kind of a skewness like this. Most probably it will be a right hand skewed data. Are you clear? Everybody just give me as in the chat box. Normal and non-normal distribution. Are you clear? What is, so I've just given very simple mundane example so that you can understand the concept. Clear hai? Very good. Now, why we are bothering about it? What is the big deal about the normality and non-normal distribution? Why? Because see, in our Lean Six Sigma, basically we do a lot of things, like for example, process capability analysis. Okay. Now let's say for process capability analysis, we underlying assumption is the data distribution is normal. Why? Because then only we can check how much data is going outside of the specification limit. This is, let's say, lower specification limit, and this is upper specification limit. So that symmetry, that normality of the data is very, very crucial for us to predict the process capability. What we do, understand is, we take a sample from the process, and from the sample, we predict the behavior of the population. Now, if the distribution is normal, our prediction about the population will be very accurate. If the data is non-normal distributed, then our prediction can go haywire. Our prediction cannot become accurate. That's why normality is a very, very important concept to be checked. Normality is a very important parameter to be checked for the data distribution, so that we can predict about the process capability accurately, precisely. Which we call 5 sigma, 4 sigma, 3 sigma. If the data is non-normal, our accuracy of the prediction will be impacted because of that. That's why we check the normality of the data. Okay, now, so how many of you remember SNC? Just type me in the chat box, which was covered in this green belt hackathon as well. If some of you attended it, SNC. How many of you remember? Just type me in the chat box. Just type me if you remember SNC. What do I mean by SNC? वाह, ओके, फंटास्टिक. चलो, कुछ लोग तो है जिनको ये पता है. SNC stands for, thank you Sudanand ji, which is stability, normality and capability. Okay, so what is stability? Stability is nothing but whether my process is stable. Okay, so SNC is what? Stability, then normality, and then capability. All the new people, just write this down, SNC, and type in the chat box with it. SNC करके type करो chat box में. And S for stability, N for normality, and C for capability. Stability क्या है? Just control chart. We check whether the process is in stable condition or not. We check whether the process is within upper and lower control limits or not. It should be stable. And in normality, we check whether it is observing a normal behavior. Okay. And then we do the process capability. Once we check the stability and normality, then only we put specification limit and check what is my current process capability, which is sigma value. 1 sigma, 2 sigma, 3 sigma, exactly which sigma we are having. Okay. So stability, normality, and cap. So today's topic, we are discussing this part, normality part. Okay. Now, so in green belt level, what we do, we cover the normality check, simple normality check, which is the Anderson-Darling normality test. Okay. What if the data is non-normal? What will happen in that case? Okay. So what we'll do, I'm just giving you quickly a Minitab file, a simple Minitab file I'm giving you. Yeah, just a second. All right. Now, first we'll do a normal, the normality check, basic normality check. Okay. Just open this file, please. Yeah. Once you open the file, let me know. वो सेम फाइल है, चॉकलेट वेट वाला फाइल. Open, just type yes in the chat box or type open in the chat box. Yeah, I'm just waiting for everybody. If you are having your laptop Minitab in front of you, then only you can do it. Otherwise, just observe what we are doing. Okay. Very good. Very good. Sure. So shall I proceed? Now, here is the data set. Okay. Now we are going to check the normality. So how do we check the normality? The first thing, the basic tool is histogram. So let's go to graph, and the fifth option is histogram. So go to graph and the fifth option is histogram. So पहले histogram करके देखते हैं. How does it look? Okay. So we will click on histogram. Always select with group, sorry, with fit, because then we'll get the normal distribution curve as well. And say okay. Now select the chocolate weight and say okay. That's it. Everybody got this kind of histogram? Just give me yes. So the first couple of things, if I draw a center like this, all right, is it looking a little symmetrical? Is it symmetrical? Just give me yes or no in the chat box. Symmetrical है ये? Okay. Is majority of the data lying in the center in this? Is majority of the data lying in the center in this pattern, in this width? Yes. Okay. So almost lag raha hai. So this is the first indication that the data is normal distributed. So histogram is a first graphical visual what you can say confirmation that the data is following the normal distribution. Now let's do a statistical confirmation. How do we do the statistical confirmation? It is done with the help of Anderson-Darling normality test. Okay, so we'll go to stat basic statistics, and the third last option is called normality test. Can you just check this option, please? Stat basic statistics normality test. Just click on that. Now you select in the variable, you select chocolate weight. And just select OK. Now this is called AD test. AD. AD stands for Anderson-Darling, which is the name given by two statisticians, Theodore Anderson and Donald Darling. Okay. So they have developed this test where we are interested in this value called p-value, this value. Okay. If the p-value is greater than 0.05, then the data is normally distributed. Now, is our p-value greater than 0.05? Just give me yes or no in the chat box. 0.05, which is 5% basically. So the answer is obviously it is 0.25, which is much higher than 0.05. So this is a confirmation that the data is normally distributed. So we have a graphical confirmation with histogram. We have a statistical confirmation with Anderson-Darling normality test. Okay, so this is a green belt wala stuff, which we already have covered, even in our hackathon as well, right? Now, what if we have a non-normal data, which is a skewed data? Okay, so let me share with you a file of a skewed data. Okay, so just download this file which I have given. इसको एक बार डाउनलोड कर लीजिए, ओपन कर लीजिए. Open this file. So how do we handle that? That is the most important stuff. Okay. Meanwhile, as you guys are opening this file, let's learn one concept. Okay. Before we go to that distribution, let's learn one concept called central limit theorem. What is that? Central limit theorem. CLT. Very good. Okay. What I'm doing, just as you are going ahead, what we are going, let's generate some data. Okay. आप अभी पहला वाला ही फाइल पे जाइए, पहले वाले चॉकलेट वेट पे जाइए एक बार. We will generate some data here just to understand the central limit theorem. Okay. एक बार सेंट्रल लिमिट थियरम एक्सप्लेन करता हूं विद प्रैक्टिकल. एवरीबडी हैज ओपन दिस. तो यहां पे कैसे जाना है? इफ वी आर ऑन दिस, इफ यू आर ऑन दिस प्लॉट, just click on show worksheet folder or just click on Control Alt D. D for data. If you are here in the probability plot, ये वाला, just press Control Alt D, which is data, or you can just click here. See my cursor. Control Alt D. Okay. Click on that. You will go back to your data set once again. All right. Just एक बार CLT सीख लेते हैं. Then we will go ahead to the data transformation. So what is CLT? Just try to understand this. Okay. So just Gauravji, just go with the flow. Go with the flow. Okay. If you don't have Minitab, just observe what we are doing. Just try to understand, try to grasp as much as possible. Even if you understand 50% also, that's good, since you are very new in the system. Today's topic is a little advanced topic. Generally, we cover in the black belt level, okay? But you see, everybody need to study everything, right? Now, coming back to this, just go to Calc. See, in the menu bar, you have File, Edit, Data, and then there is a calculator. Okay. There is a random data. So in the Calc, the third last option is random data. Can just check random data and just check normal. Just follow this path, please. Go to Calc, random data, normal. Now we are going to generate, understand this. What we are going to generate is, we are going to generate some data from the Minitab. Okay. We are generating, first we'll generate some 5 to 6 data points, then we'll generate some 100 data points, then we'll generate 500, 5,000, 50,000 data points. It depends. Okay. Now, so calc random data normal, select that. Now, number of rows of data to generate. Here, we will generate first the 5 data points. Just press 5 and store in the column. Store in the column C3, because C1 is column number 1, C2 is column number 2, C3 is empty column. So we are generating 5 new data points in column number 3. Everybody with me? And just type OK in the chat box. Sorry, just click on OK. You will get 5 random data generated. I repeat the same process. Just go to Calc, random data, normal. Just select 5 number of rows. That means I want to generate 5 data points. I want that to be stored in C3 column number 3, and just click on OK. You will get these random 5 numbers. Everybody with me? Just give me yes in the chat box. Or you can open any fresh Minitab file as well, and you can do this exercise. Yeah, got it? 5. Now your numbers would be different than my number. It's okay. That doesn't matter. We'll understand the concept first. Okay. Now let's repeat the same process. Repeat the same process. Now, if you want to repeat the same process, you don't have to go to Calc, etc., etc. You just can go, just press Control E. Can you just press Control E? The same window will appear once again. Just press Control E, the same window will appear. Now here, we will generate 50 data points in the next column called C4. So first we generated 5 in the C3 column. Now we have generated 50 in C4 column. Just click on OK, and 50 random data will be generated. The same procedure we will do it for, let's say, 5,000 data points in the C5 column. Click on OK. So I've got 50, I've got 5, 50, and 5,000. All right. Now I'll go to graph. I will go to histogram. Go to graph and histogram, the same thing what we have done. Now, instead of chocolate weight, select all the three. Okay. C3, C4, and C5. You can select all the three and click on OK. Wow. Amazing. So have you got this kind of a, how many of you got this kind of a distribution data? Yes. See, yours will be a little different because the data generated will be different. Everybody got it? Just give me yes in the chat box. Very good. Very good. Super. Let's try to understand. Let's try to decode this. This was for the 5 data points. This was for the 50 data points. This was for the 5,000 data points. Now tell me, number one, this one, is it normal distribution? Give me yes or no in the chat box. Everybody type yes or no in the chat box. No, right? It is not normal distribution. This distribution, it's called as uniform distribution. Write this down, uniform. Why? Because even though it looks symmetrical, but majority of the data is not in the center. Okay. All the data points are having only one frequency, which is 1. That's why. So uniform distribution looks like a rectangle. Are you understanding? Yes. It looks like a rectangle or a square. This is called uniform distribution. Uniform distribution is not normal distribution. Now let's coming back to number 2. Is it normal distribution? Second number graph, is it normal distribution? Just give me yes, no in the chat box. Partial, okay? But from the first, it has at least taken some kind of a shape of the normal distribution. Yes or no? Now the data has started emerging in the center more. Okay. And it is showing a little bit of normal behavior, symmetrical behavior. Let's come back to number 3. Is it normal distribution? Absolutely yes. Yes or no? So the first is, it is no, there is no norm, it is non-normal distribution, or no, it's not normal distribution. It is a little normal distribution. And this one, you can say it is perfect normal distribution. Now, just try to understand this. What is the difference between these 3 distribution? Is the number of data points. Is the number of data points. Okay. So what we should learn from here, as you increase the number of data points in the data set, in your sample, as you increase the sample size, naturally, why I said no, why it is called as normal distribution. Naturally, the distribution will take the shape of normal distribution. And this theorem is called as central limit theorem. Are you clear with this theorem? As you increase the sample size, the data will start taking the normal distribution. Just give me yes in the chat box if you have understood this with practical. Now we have randomly generated the data, and now practically you can see the difference between the 3 distributions. Clear? So the first thing, so what is a learning? Whenever you come across non-normal data, try to increase the sample size. Try to increase the sample size to get it to the normal distribution. Clear, everybody? Just give me yes in the chat box. We are learning how do we handle non-normal distribution. So the first strategy is increase the sample size first and then check the normality once again. Clear, everybody? Just give me yes in the chat box. First strategy clear है, sample size को increase करना है. ठीक है जी? Okay. Very good. Now let me open the other data file. Yeah, have you opened the file, the second file? The file's name is, I think, lab time transformation. Just click on the red cross and just save no. Don't save anything because we are using this file multiple times, so don't have to save anything. If you want to save, you can save. You can, if you want to make a separate folder out of it, you can do it. Okay. All right. Once you open the file, let me know. File opened. Now there is a lab data, time data. If you remember, I mentioned whenever there is a time related data, you can see some kind of a skewness in the data, which we are going to observe now. Okay. Let's look at this column called C2 column. Okay. This is the data where we want to now check the normality. Everybody open the file. Just give me yes in the chat box so that we can start. जिनके पास अभी Minitab नहीं है, just observe what we are doing. I'm going to give you both these files, okay, in the masterclass archive so that you can do the practice later. Start the recording and then you can do the practice along with it, okay? Now, let's first make a histogram. The same process. Histogram karo with fit. Now you can do it faster. The column is time. Just double click on time. Say okay. I will hope you have the laptop with Minitab. Okay, then only it will open. I'll share the file once again. Just a second. Yeah, meanwhile, other people can do this. Just go to graph, go to histogram, and just do the histogram first. Okay. Now, you would get this kind of a histogram. Everybody got it? Just give me yes in the chat box. Yes, got it, everybody? Now tell me, is it normal distribution, non-normal distribution? What is the distribution looking like? If you draw a line, it would look like this, isn't it? Just a second, let me just draw it once again. So if I have to draw, it would be like this, correct? Yes, which is showing a right-hand side skewed, exactly. So it is showing RHS, which is right-hand skewed distribution because the tail is extending on the right side. You have got extreme value on the right side. Okay, that's why it is called right-hand side skewed. It is non-normal distribution. Now, how do we confirm that? Again, go to the normality test. Normality test kya hai? Again, basic statistics normality test. Now you can do it faster. Select the time data. Click on OK and check the p-value. Remember, p-value should be greater than 0.05. In this case, it is less than 0.005. All right. So it is a clear confirmation that it is a non-normal distribution. Now, the first thing, correct? It's a non-normal, right? Now, the first thing is try to increase the sample size. Sample size ko increase karo. Okay. Generally, understand this. Generally, for continuous data, you should minimum have 30 data points, 30. Okay, right? So make sure that you have 30 or more data points. All right. And if this kind of behavior, non-normal behavior is observed, just try to, whatever is the number, try to increase the numbers, try to increase the sample size. That's the point number one. Sometimes, even after increasing sample size, the behavior remains same. The non-normal behavior remains same, right? How do we handle that? That's where the data transformation comes into picture. All right. So how do we handle this? Let's try to understand this. How do we handle this data transformation? So there is something called, so two strategies I'm going to explain. One is called Box-Cox. Second is Johnson transformation. Both these strategies are very important, for us to understand. So how do we do that? Go to stat, control chart, Box-Cox transformation. Everybody just follow this. Stat, control chart, Box-Cox transformation. So this is when, after increasing the sample size, understand this. Now, just to explain, give you the context, okay? Now, whenever we have, some medical emergency where doctor, gives us option of operation only. Understand this. Operation, doctor will only give the operation as a option at the last resort. First, initially, they will try their level best to avoid that. So transformation is just like that only. Transformation you should be doing only when it is not getting normally distributed data. Are you understanding? Okay. So make sure transformation is used very seldomly and very rarely. Okay. So this is the context. Okay. Now let's go to control chart and Box-Cox transformation. Just click on that. Here, just select a time because the data is there in the time column. Subgroup size is 1 and click on OK. Everybody got this? Box-Cox plot. Just give me yes in the chat box. सबको मिला ये Box-Cox plot मिला? What we are interested in, this final value, which is 0.00, which is 0 basically. And this is called lambda. So this lambda value is right now 0. Now, what does it mean? What does this lambda 0 mean? That is what we are going to learn right now. Okay. Now, so in your curriculum, this table has been given, which I'm showing you right now. This table has been given. Just try to understand this. This is called the transformation table or a power transformation table. Just try to understand. So the value which we are referring is the lambda value. Okay. And this lambda 0, which shows what kind of transformation you have to do? Log transformation. Y meaning the data set. Y ka matlab hai the data set which we are referring, the time data. Okay. So what is log? Try to understand it. How many of you remember log tables we used to use in our schools and colleges, 11, 12 standards, or our school 10 standard log table? Do you remember log tables being used? Just give me yes in the chat. How many of you remember log tables? Those small booklets we used to use where, all the numbers were there, right? Correct. Very good. Very good. So in the black belt level, no, we calculate manual. I'll give you those log tables and those T distribution tables. Okay. Base 10 or base E exponential, E for exponential. Very good. Very good. So you guys still remember all those things, huh? Itne saalon ke baad bhi. That's amazing. Okay. So let's say, what is log? Try to understand this. For example, let's say, let me write in white. Okay. Let's say, for example, so 10 to the, to the power 1, meaning 10 raised to 1 is what? 10, right? 10 ka square is equal to 100. 10 ka cube is equal to 1000. Correct? We all know this. Now, so what is the log of 10? So log of 1. No, sorry. Log of 10 to the base 10 is 1. Log of 100 to the base 10 is 2. Log of 1000 to the base 10 is 3. So whenever there is 10, we are not going to use 10, we are going to use 1. Whenever there is a value 100, we are not going to use 100, we are going to use value of 2. Whenever there is a value 1000, we are not going to use 1000, we are going to use value of 3. So this is called a log transformation. Are you understanding? We don't have to worry about it. Software will do it for us. Clear? Log transformation. What is that log? So if the value is 10, we are not going to use 10. We are going to use the log value of 10 is 1. Log value of 100 is 2. Log value of 1000 is 3. Everybody with me? Just give me yes in the chat box. So accordingly, software will change, Minitab will change the original value to the log values, and then they will check the distribution. Okay, हम लोग अभी करके देखते हैं. Clear? Now, how do we change that? Let's go back to the value, go back to the data. Now, before that, let me explain you the other data tables as well. Let's say lambda, if the lambda is 0.5, this one, okay, you have to take square root of y. If the value is 100, you have to take 10. If the value is 4, you have to take 2. Are you understanding? So square root of the data. If the lambda is 1, there is no transformation required. Generally, it is a normal distribution. If lambda is 2, then you have to take the square value. Instead of 10, you take 100. Instead of 4, you take 16. You take the squared value. And then you take the distribution, that will be normal distribution. Are you understanding? Similarly, if you go on the downside, which is, if it is minus, lambda is minus 0.5, you take reciprocal square root, which is 1 divided by square root of your value. If it is minus 1, then reciprocal, 1 divided by that value. Okay. If lambda, if I extend this further, it can go further. Like if lambda is minus 2, it will be 1 divided by square. Okay. If lambda is minus 3, then 1 divided by cube, and so on and so forth. Okay. If lambda is minus 4, then 1 divided by the y raised to 4. Similarly, it goes on the upper side as well. If lambda is equal to 3, then you have to take the cube of it. If lambda is equal to 4, then you have to take the fourth power of it, raised to 4. Are you clear? So similarly, दोनों भी पीछे और नीचे. So generally lambda value is between minus 5 to plus 5 तक होता है generally. Just for your information. Clear है? Everybody with me till now? Just give me yes in the chat box. So now we will do this log transformation. Okay. So you don't have to manually do it. Software will calculate it for us. Okay. Let's do this. Go to the data once again. Open our file. And we will go for this distribution. Okay. So I told you earlier, from the graph, how do you go back to the data file? Just Control Alt D. Correct? So we have reached to this data point, right? Now, just focus here for next 5 minutes. I will give you exact procedure for converting that into the log data. Okay. So I will go to calc and go to calculator. The first option is calculator. Just click on that, calc and calculator. Go to calc. The first option itself in that is calculator. Just click on that. Okay. Now the first thing what they're asking is store result in the variable. So we'll select C5. So whichever column is empty, we have to select that. So in that column, I will transform the data. Okay. The original data is time column, C2 column ko I want to transform into a log data. So I will put it in the C5 column. Okay. Now the expression. So for expression, now identify the log value here. Okay. So what you can do here in the function column, either you can select the drop down and select the logarithm. Can you see here in the function, all function ka log drop down click karo and just select the logarithm and select log to the base 10. Now, how do you select it? Double click on that. Everybody with me? I'll just repeat the entire process once again. I close this, go to calc, calculator, variable column, C5 may I want to store the result. Now in the all function, I am selecting logarithm. and I'm double clicking on log base 10. The moment I double click over here, expression mein what it is written, log 10 in bracket, there is which column you want to change. So once you double click on that, you have to double click on time. Now time is selected. Everybody with me? So यहाँ पे select function logarithm log to the double click on log base 10 and then double click on time. So you will have log 10 in bracket time. If you have this, then just click on OK. And now you have in the C5 column, this is all log data. So I'm just giving the name called log. Are you understanding? So here, let me scroll down. Can you see here row number 24? Just observe here, guys. You remember I mentioned earlier the log का value, right? हाँ मैं repeat करता हूँ. So just remember this, ना? Log to the 1 is 10 raised to 1 is 10, right? So log of 10 is equal to 1. 10 raised to 2 is equal to 100. So log of 100 is equal to 2. Remember this? Log of 1000 is equal to 3. So here, if you see the row number 24, this row, okay? So the value is 100 and the log value is 2. Can you see here? The original value is 100 and the log value is 2. Just give me yes in the chat box. Just give me yes. Have you observed this? Yes. So it has been transformed to the log value. Okay. हाँ मैं आपको फिर से दिखाता हूँ किरण जी. Look at this. Go to calculator. Okay. Select the column where you want to store the data, store the result. So we have selected C5 column. Okay. Then we went to the all function and selected logarithm function. Then we selected log to the base 10. So let me remove this. Then we selected double click on log to the base 10, and in that bracket we double click on time because we want to convert that time wala column into log to the base 10, and then we click on OK and we got this entire column. Okay, now let's do the histogram. Let's do the histogram. Graph, histogram with fit. Now instead of time, let's select log. Okay, select both. Let's say select both. Okay, first select time and then you select log and click on OK. Can you see both these histograms? This was the original one. The left side is the original one and the right side is the after transformation. Clear, everybody? Just give me a chat box. See, now can you tell me, is it normal distributed? The second one? Just give me yes or no in the chat box. But what about from the original one? Okay, so first graphically, see, this was the original distribution. Now, can we say it is looking a little normal rather than skewed, correct? Majority of the data set in the center and it is symmetrical. So these are the two parameters, majority of the data set in the center and symmetrical distribution. How do we confirm that? How do we confirm that? Type in the chat box. So this is a graphical representation. What is the statistical confirmation? Which test? AD test, Anderson-Darling normality test. Let's do this. Exactly, we have to. So let's go for AD test. Again, software will calculate, software will do its level best to do this. Okay. Now select the log data, say OK. Wow. Can you see the p-value earlier was less? Now it is 0.299. Remember our criteria, if the p-value is greater than 0.05, it shows the normal distribution pattern. So this is a confirmation that the data has been transformed to the normal distribution. Are you clear? Just give me yes in the chat box. Clear hai? Yes, got it? So what we have done, we have transformed the earlier data, which was a non-normal data, which was a skewed data, to a normally behaved data. Now we can do the process capability analysis. Okay. Now we can do the process capability. How do we do process capability analysis? Let's find out. Let's imagine. Now, for doing the process capability analysis, what do we need? Type in the chat box. Again, understand my question. For doing process capability analysis, what do we need? Type in the chat box, everybody. Think about it. Process capability is ability of the process to satisfy the customer requirement. So what do we need here? Everybody, I want everybody to answer this question. Data तो है ना अपने पास, data तो है. Data in the time column we have a stable and normal data we have. We have checked the stability, we have checked the normality. It was not normal, we have transformed that. Now what do we need? To check my process capability. I want everybody to understand the question and answer it. I'm just waiting for it. People are answering that, but I want everybody to think. Scratch your head. Isme what is still missing? That, see, process capability is what the sigma level will calculate. Fantastic. So what is missing is customer requirement. No. What is process capability? Ability of the process to satisfy customer requirement. Ability of the process to satisfy customer requirement. For example, if the customer requirement is 30-minute pizza delivery, is your process capable to deliver within 30 minutes? That is process capability, right? Is your process capable? So what we have collected the data, but now we want a specification limit, which is customer requirement, correct? So imagine this, for this particular case, the USL and LSL. Okay. So let's say LSL is 40 and USL is 400. I'm just giving you a very random numbers. Okay. So what we have to do instead, so this is 40. So 40 ke liye we have this value. Okay. Can somebody write this value in your notepad somewhere? Or just type in the chat box. Everybody just type LSL 1.60206. This is a log value, no? This is actual value, correct? Because we have transformed that data into log. Now we are using this, okay? And for 400, let me just scroll it down. For 400, let me check if I have any. Yeah, so I have got this value, which is 2.60206. Okay, fantastic. So this is very good to remember. 2.60206. So after decimal, the values are same. Okay. Here you can see 400 का ये value आपको दिख जाएगा. Yes. So 60206 आपको remember करना है. That's it. Okay. चलिए. So we will put it in the specification limits. How do we do that? Go to stat, quality tools, capability analysis, normal. Everybody follow this? Stat, quality tool, capability analysis, normal. Click on that. Which column data? We have log data, because that is the data we want to transform. Okay. Subgroup size is 1. Just place 1 there. Lower specification limit is 1 point. What was that? What was that value? Anybody has written that value? 60206, correct? and upper specification is 2.60206. Everybody with me? Upper and lower specification. All right. Lower is 1.60206. Upper is 2.60206. Okay. Go to option and select benchmark Z. Here, just click on benchmark Z here, which will give us directly our sigma value. Okay. Click on OK and then click on OK. So our current process capability is 1.21 sigma. So our current process is 1.21 sigma process. Everybody got this? Just give me yes in the chat box. Got it, everybody? This is the way you can transform the data and you can do the process capability analysis as well. Yes, got this? So whenever you come across non-normal distribution, the first one is, okay, the first one is to increase the sample size. Okay, don't do transformation immediately. Transformation is a just operation. It's a last resort. Okay, just do the just increase sample size and then do the normally test once again. Okay, even if it is not happening, see there are other ways of doing it as well. Okay, there is something called scale change. Just try to understand this. See, we are learning here various ways to handle non-normality, right? So there is something called scale change as well. Let me just write down over here. Scale change. What is scale change? Let's say, for example, if you have the data in, in foot, okay, how many feet data is there? 2.1, 2.2, etc. So instead of that, you are changing into inches or centimeters or millimeters. Okay. Or if you have degree centigrade data, degree centigrade data, instead of that, you change it to degree Fahrenheit. That also is one strategy which is called a scale change strategy. So instead of degree centigrade, you take the data in degree Fahrenheit and then you check whether it is following the normal distribution pattern as well. Okay, so this is called a scale change strategy of transformation. Okay, are you clear, everybody? So whenever it is possible, you can do a scale change as well. So increase number of sample size, increase the scale change. You can do the Box-Cox transformation. Sometimes even after Box-Cox transformation also, the data does not transform into normal distribution. Okay, so there is one option we have which is called as Johnson transformation. Johnson transformation. Okay, now when do we use Johnson transformation? When Box-Cox does not transform. Okay, so where Box-Cox, you can say a little fails, you can say Box-Cox fails. And second criteria is whenever you have negative numbers. Okay, minus 10 degrees centigrade, minus 20 degrees. They're negative numbers, no? Meaning below zero, basically. Negative meaning below zero numbers. You should use the Johnson transformation instead of Box-Cox transformation. Clear, everybody? Just give me yes in the chat box. Everybody with me? So we will learn the another concept called Johnson transformation today as well. Johnson transformation, a little, what you can say, complex transformation to explain, but we will practically do it just to check how we can handle this. Okay. So let's go back to the data once again. Let's go back to the data. I'll just show you the transformation of the data. That's it. Okay. How do we go back to the data? This one. Okay. Now, what we will do, go to stat quality tools, and here is Johnson transformation. You will see stat quality tools, Johnson transformation. Everybody follow this? Stat quality tools, Johnson transformation. Just click on that. The same thing, single column is the time data. Okay. Now, here you have to say store transform data in which column? Let's say C6 column. So write C6. Here you have to just type kahan pe wo dalna hai. Now, when you go to option, just try to understand this. Okay. When you go to option, by default, p-value select best fit is 0.10. I generally do not change this setting. Okay, I would rather suggest you also should keep it as it is. Don't change it anything. Just click on OK and click on OK. Now, look at this. You will get this graph first. Okay. So we are not going into the detail. This is our original data. We have seen the p-value was less. Now with the Johnson transformation, the p-value has become 0.680, which is showing the normal distribution. Okay. And this is the equation. And again, it is, as I said, it is a little difficult to understand, but what we are interested in the transformed values. Okay. Let's go back to the data and the C6 column. Let's name the column called Johnson. Okay. So what we have done, we have just done the Johnson transformation in this. Now just we'll check now the time data and the Johnson data. Okay. एक बार उसको चेक करते हैं. ग्राफ में जाके histogram with fit, select the time data and select the Johnson data and just click on OK. Now you can see here. So this is also one strategy available where, earlier it was a non-normal distribution. You have seen that. Now with the Johnson transformation, it is showing much better symmetrical distribution for us. Clear, everybody? Just give me yes in the chat box. So what we have seen various strategies. First of all, let me quickly revise. Okay. Now, we have seen first the normality test. How do we check normality? How do we check? Histogram, which gives us the, okay, let me write down. That will be better for you as well. Okay. Let me summarize this entire stuff for you quickly. Very good. Super. So first we spoke about the difference between normal and non-normal, right? With that example of the biometric system. Everybody with me? Just give me yes. Okay. Then we learn about stability, normality, and capability. SNC. Just give me yes. Remember, yes. Stability is control chart. So stability we did not check today, but normality. Then we check the normality with Anderson-Darling test, AD test, where the p-value should be greater than 0.05. If it is greater than 0.05, the data is normal. If no, then we go for the transformation. Okay. Then today we learn the concept of something called CLT, central limit theorem, in which practically we have understood when there are less number of data points, it was not showing normal behavior. When we increase the sample size to 50 to 5,000, it took the perfect normal distribution shape. Okay. So the first strategy is whenever you come across such thing, then you can increase the sample size. Okay. So the first strategy is increase the sample size. Okay. Then the second strategy we have seen is maybe you can change the scale. That is also a very important strategy. Change the scale of the data. If the data is in inches, to convert into centimeter or millimeter, etc. If the data is in degree Fahrenheit, degree centigrade, convert into degree Fahrenheit, etc. Okay. So changing the scale also, you can change the shape of the data transformation, data distribution. Okay. After that, we have learned the Box-Cox transformation, right? Where we have checked the lambda value and we have a table, standard table, which will guide us what kind of data transformation you can do. Okay. In this case, we have learned the log transformation, right? If the even after Box-Cox transformation, also sometimes the data shows non-normal behavior. So there we can use Johnson transformation. Okay. So when the Box-Cox fails or you have a negative numbers in your data set, then you can go for Johnson transformation. This is what we have learned in the today's class. Everybody clear? Understood all this step-by-step procedure? Just give me yes in the chat box. It might be a little advanced for the new people, but if you sit with the open mind, you can understand the concepts. Clear, hai? Just take a quick screenshot. The recording will be available. The data files will be available in, available in the masterclass archive. Okay. Change scale, why required for normality? See, if the data is non-normal, then try to change the scale as well. That is also one strategy I've given you. If possible, okay. I've given you a couple of examples, degree centigrade, feet to or inches to centimeter, etc. Okay. By doing that, also you can change the shape of the distribution. If from non-normal it turns to a normal distribution, then that will serve the purpose. Okay. That's what I mean. So that is also one strategy. So increase sample size, changing the scale, or Box-Cox transformation, Johnson transformation. And as I said earlier, transformation is the last resort, just like an operation done by the doctor. Okay. So doctor first will give you medication, first will give you, this thing, right? Some exercises, some change in your, this thing. Okay. Then we say convert the scale, but here is another things. If one data in meter, other in centimeter. No, see, meter centimeter there will may not be much difference, but if the data is in centimeter, you convert into inches, then there will be some kind of, what you can say, changes can happen. Okay. See, what you need to do is now, in Excel, okay, collect the data. Let's say if you collect the data in centimeter, and then in the next column, you convert that data into inches. Okay. And then you copy that data in the Minitab and check whether the non-normal distribution has been transformed. If no, just go to the Box-Cox transformation. If yes, your problem is solved. If the data is transformed, or if the shape has transformed, then your problem is solved. Because what happens is histogram, when the histogram is made, sometimes by changing the scale also it takes the normal distribution shape. Okay. एक बार ये try करके देखना है हमें. See, there is no straight jacketed answer what will hit. Okay. So you have to basically, what you can say, try ये trial and error का वाला system है. Okay. तो आपको try करना है इसमें. Clear, everybody? Just give me yes in the chat box. So did you learn something new? It's a little difficult today. Kiran ji says it's difficult. But have you understood the concept? See, what is difficulty? Difficulty meaning because you are learning it first time. Because there is no concept right now in your neural pathway right now. So I've created a new pathway. So you learned today Box-Cox, you learned today Johnson transformation. Okay. How do you handle non-normal distribution, which was not there in your mind first. That's why you are a little struggling. The moment you repeat this concept multiple times, then it will be very easy peasy for you. Okay. Box-Cox transformation process capability found 1.21. Does it mean plus within 1.21 sigma meaning? Just to explain this, what does 1.21 sigma mean? Okay. What is the formula for Z calculation? The formula for Z calculation is this. Okay. Upper specification limit minus X bar divided by sigma. Okay. So how many, for example, so this is a formula for Z. Z meaning what? Z in this case was 1.2, 1.21. This was Z. See, when we say 6 sigma, no, this 6 number is actually the Z value. That Z score is 6 sigma. Okay, so what does 1.21 means? Let's say this is X bar, which is our mean. Okay, and this is upper specification limit. I can fit, let's say 1 sigma. Sigma is standard deviation, and then 0.2 sigma, which is very close to. So the total is 1.21 sigma. So I can fit between X bar and upper specification limit 1.21 standard deviation in between. Okay. इसके लिए मैं I will take a separate session on this, but the same can be. So when I say what my assumptions are, the X bar is in the center, okay, and if I can fit 1.2 in one side, I can fit 1.2 on the other side as well, which is on the lower specification side as well. Okay, I can fit 1.2 standard deviation. See, when I say 6 sigma process, understand this. Okay, upper and lower, and this is my X bar. Try to understand this. I can fit 1, 2, 3, 4, 5, and 6 standard deviation between my mean and upper specification limit. Just try to understand this. Just for our understanding. Okay. Similarly, on the left hand side, lower specification limit maybe I can fit 6 standard deviation. That means total I can fit 12 standard deviation between upper and lower specification limit. That is called a 6 sigma process. एक side में ही 6 standard deviation I can fit. Now when I say I can fit, that means I have to reduce my standard deviation sigma such that I can fit more sigmas between my specification limit and my mean. Okay, this is just for our understanding. So as the spread of the distribution will go reduced, standard deviation will reduce, and we can fit more sigmas between specification limit and mean. Okay, just to answer this question. So the process capability calculation remains same. Only changes, we have just transformed the data from the non-normal distribution to normal distribution, just so that our predictability will become more accurate. That's the only difference. Super. So for this na Z value calculation wale ke liye, I will take a separate class so that you guys can understand. Okay. Super guys. So I hope you guys have understood today something different. Very interesting topic of the black belt. Okay. Thanks for joining. We'll connect again tomorrow. Now, tomorrow is a yellow belt session. If you want to refer somebody, you can refer, and you can get your referral bonus of 4,000 rupees. All right. And we will connect again on Monday with a new topic with the same enthusiasm. Till the time, keep learning, keep growing. This is Dinesh Patil signing off.